Okay, in this problem here we are going to evaluate this integral of cosine x minus 3 dx, and the lower interval is going to be negative 9 pi over 2 and the upper is positive 9 pi over 2. So we're going to need a little bit of trig and knowing what the cosine or sine of a trig function is. We'll get to that a little bit later. But let's start off by finding the antiderivative of cosine x. Well, let's see. That's easy enough, right? Sine. The derivative of sine would get you back to cosine here. And the antiderivative of negative 3 is negative 3x. All right? And we're going to evaluate this between negative 9 pi over 2 up to positive 9 pi over 2. And the fundamental theorem of calculus, here I'm just going to slide this down, fundamental theorem of calculus says to rewrite this thing. So let me rewrite it this way. All right, let me rewrite it this way. I've got the sine of 9 pi over 2 minus 3 times 9 pi over 2. All right, that's where everywhere I see an x, I'm plugging in a 9 pi over 2. All right, and minus the quantity sine of negative 9 pi over 2 minus 3 times the quantity negative 9 pi over 2. And in this case here, everywhere I saw an x, I plugged in a negative 9 pi over 2. Hope that's easy to see. All right, so I got to work all of this out here. We're going to work out each of these quantities and take the difference between them. Well, before I do that, all right, before I do that, let me just review something with you real quickly here. Let me open up another sheet. And that is, when you're dealing with 9 pi over 2, for example, all right, if this is where 0 is right here, I hope you see that, or remember from your trig days, that half of a circle, half of a rotation, or 180 degrees, is the same thing as pi. All right, which means then that 90 degrees is the same thing as pi over 2 radians. Okay, so but we're dealing with 9 pi over 2. All right, we'll deal with negative 9 pi over 2 in just a second, but let's deal with the positive here, 9 pi over 2. Where does that land us? Well, take a look at this. I'll do it in a different color. All right, see if you can follow along. If this much here is pi over 2, and going another 90 degrees must be 2 pi over 2, and sure enough, 2 pi over 2, well, that's the 2's just cross out, and we're at pi, right? So that works. If we go another 90 degrees, that lands us at 3 pi over 2. And if we go another 90 degrees, that gets us to 4 pi over 2. But you know that 4 pi over 2 simplifies down to just 2 pi, and 2 pi is just one full rotation. All right, well, let's keep going. This is 5 pi, 6 pi over 2, 7 pi over 2, 8 pi over 2, 9 pi over 2. Oh, so 9 pi over 2 is really the exact same radian as pi over 2. And I hope you see that if I went in the opposite direction, right, negative 9 pi over 2, I would just go in the opposite direction. This is negative 1 pi over 2, negative 2 pi over 2, negative 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi. So negative 9 pi over 2 is really the same thing as saying negative pi over 2. Right? It's the same thing as going in this direction here. It lands me in this negative pi over 2. Okay, so knowing those two things then, if you want, you can rewrite this original, these original values here. Instead of as sine of 9 pi over 2, you could write that as sine of pi over 2. And instead of writing this one over here as sine negative 9 pi over 2, I could write this as sine of negative pi over 2. All right, so I don't know if that helps. All right, I'm going to simplify these a little bit more, as well as what I've got remaining over here. But let's go back to this for a second. What is the sine of 90 degrees? Okay, well, the sine of 90 degrees, or pi over 2, is equal to just a positive 1. And similarly, the sine of negative 90 degrees, or negative pi over 2, is equal to negative 1. Oh, so back to this. this evaluates, the sine pi over 2 simply evaluates to a positive 1, whereas this one here evaluates to a negative 1. Alright, let's keep going here. What I have in this spot here, let's see, I'm just going to multiply 3 times 9 since they're both in the numerators, and I've got a negative 27 pi over 2. Likewise, here I'm just going to bring that minus sign on down. Likewise, for this one here, I've got a negative 3 times a negative 9 in the numerator, so that's a positive 27 pi all over 2. Okay, but what does this minus sign in the middle, right, and that minus sign again comes from the fundamental theorem of calculus, what does that minus sign in the middle do to both of these terms after it? Well, it changes their signs, right? So what I then have is this. I'm going to take the parentheses or the brackets away now. I've got 1 minus 27 pi over 2, right? And this negative times that negative makes it plus 1. And that negative times that positive makes it another minus 27 pi over 2. Well, I hope you see that these two are similar, right? 1 plus 1 is obviously 2. It's easy enough. And if I've got negative 27 pi over 2 added to another negative 27 pi over 2, I really have, from these two guys, I really have a negative 54 pi over 2. Common denominator stays the same of 2. Hey, but 2 goes into 54 27 times, so I've got a negative 27 pi. No longer have a 2 on the bottom, right, because 2 goes into 54 27 times. And there is my final answer in terms of pi. 2 minus 27 pi. Hope that helps and makes sense.